Hey everybody, this is Brad Dyke reaching out to you to say hi, how you doing? The reason why I was reaching out to you is I started this video a couple days ago and it was still 2024, but the encoders and the codexes kind of went bad on it and was a bad combination of issues, and so I said, just forget it. I'll start over and do this again. Besides, I caught some things I wanted to clean up a little bit. Anyways, so this video, I guess, is technically my first video for 2025. Is about some projects I wanted you guys' input on, if you're interested. If you're not, that's fine too. And kind of give you an idea of some of the ideas I was thinking about doing to kind of get, into the mode of working with what I've got, but at the same point in time, somewhat limited in funds, so I'm going to do the best I can. So the principal three initial projects that I'm looking at doing are one's related to scaling a dead chassis I've got here, which is a DL380 Gen 9, and that's over there. I'll point that out in a second. And the second one is to rebuild all the Proxmox environments I have to the latest release version, and then realign them and walk through the improvements and things like that. May they be up there on my small thin client strategy or my full-blown 2Us that I have out here, both of which are very valuable in totally different ways. And then my third one, which is really cool, which involves building a brand new server from scratch using warranty parts. Let me explain that to you just so you understand. When I talk about a brand new server, what I'm referring to is that when companies like HP, Dell, Lenovo, and so on bring new product out in the industry, they have to store a certain amount of those components in a warranty warehouse. And then as this equipment begins to phase out, which is just within about 3 years, they've got to quickly dump the market out, get a clearinghouse. The clearinghouse focuses on getting rid of the gear, and they restock it for the next model of hardware that they're going to put under warranty. So, two critical details about this, and I've done a video on this if you want to look it up. Warranty components are brand spanking new. And not only that, because you have all the span of the new hardware, and you learn all the lessons learned, firmware updates, whatever needs to be done up front. So when you do get the warranty hardware and you pull that in, you get not only brand new hardware never used before, may it be as simple as a fan, like for instance, brand spanking new chassis fan, which these have never spun for any functional capacity until I bought them, to the ability of having them completely optimized and streamlined, because we've already learned the lessons with the brand new hardware that it was originally sold to support. So with that, I'm going to build a project chassis, a 2U chassis that is going to be dedicated to AI related support roles. Now, what does that mean? It means this is a highly compatible 2U chassis that is designed to support GPUs while utilizing a Intel-based core processing for control processing. We'll get into that, but let's start off first with our first project, which is the DL380 Gen 9, which I had leftover parts for when I built my Proxmox unit. And I'm thinking, I think it's time to bring that guy to full life as well. So, if you remember early last year, I built this multimedia design chassis from warranty components and from parts from another chassis over here, which is basically not really working. And then over here, I had processors, memory, and so on, and this became one of my two primary Proxmox high-end compute platforms, which has got some limited disk capacity to it, but principally it's focused on processing power. And then down here I've got an XD, I'm sorry, not an XD, this is, over here is an XD 740, but this is a Dell PowerEdge 740 media style footprint, which, as you can see, it has 8 bays, open bay, media station, and then down here is a larger version of the same model. But principally, one is a compute engine, which is this one, and it's going to work with this guy as my Proxmox high-end platforming. Now, of course, down here I have a quad high-end Xeon for my database processing, but I don't usually do that much because I don't like databases really. But here, this guy is dead. He doesn't work. He's not functional. He's parts, pieces, and so on. So as I pull it out there, you'll see that it's kind of empty inside. So my thought is, let's bring this guy to life. Let's put in the third disk capacity configuration and get that running. And then at that point in stage, I'll have enough capacity here. I've got plenty of old style 3.5-inch drives that can act as caching drives. But I really want just the RAM and the CPU mostly, because I'll use my NFS 10 gig bandwidth for storage capacity. So that was my thought, and I'm going to again use the same trick with warranty parts to be able to build this out correctly, so that it's going to be able to join down here with this compute unit and of course its brother compute unit, which is also a Gen 9 as well. So with that being said, that's going to require processors, it's going to require memory, it's going to require fans, it's going to require some components which I will source out at dirt cheap prices, and at that point stage I'll take it from there. Now of course I could also do something like upgrade to a 12 gigabyte SAS controller, but that's for another time. So with that being said, this relates to my second project, which is once I've done this, you have to understand if you're using Proxmox on the free, you really don't get any functional upgrades or anything like that. So it's been about a year now since I've been on Proxmox, and unlike my TrueNAS, which does scale up and upgrade over time as long as it's in a free state, Proxmox doesn't do that. So my next strategy is this. So what my thought is, I have high compute Proxmox clustering, and I have thin line Proxmox clustering up here, which has its resources, and there's quite a bit of firepower here as well. Granted, it has to be better striped across the units to better balance it, unlike the high CPU capacities I have on these 2Us. And that is a value, by the way, where you're saving money by not investing a lot of money here. You're divesting space and resources by using a 2U model instead. And of course you need 2 of these for a Proxmox cluster to work effectively, and 3 if you want to do scaling. But principally here, as you can see, these guys all have their overhead as well, and so my thought is I'm going to rebuild these guys clean and using the newest, greatest version of Proxmox, and do lessons learned on the differences between the old and the new and improvements, and I would relate that to you guys to see what you thought about that. So with that, that's one project idea that I had that I was thinking about doing. So by diversifying the strategy of my Proxmox and starting to do some advanced servicing, it will allow me to start doing more service designing, which is something I've been trying to do. I told you that there's a game out there called X4 Foundations, and you can superimpose any data center, any cloud model, anything you want over this game, and you do your star bases and your ships and your freighters and your defense mechanisms and all that as replacements for CI/CD, auto coding, product engine running, and so on and so on and so on. So I can actually simulate a business model using a computer game. It takes a little bit of interpretation, but it's really a fun game to play. But I can do the same thing now more effectively if I do scale up my Proxmox, and I do recommend that nobody get too comfortable with any particular version of Proxmox. You need to be able to blow it away, bring it back, bring it in clean, do transition modeling where you have old and new in the equation, and so on and so on. I'm going to do that with this newer version. I didn't even consider it in the older version because it would just be too big of a headache. But I think there's a way to break Proxmox so that you can do that and drop a node, upgrade it, bring it back in, and then put it back into the cluster, then drop the other node down and do the same thing, and you still have all of your instances, your data, and so on. But it is time consuming if this plan works, but it's part of the equation. Anyways, let me know what you guys think about project number 2. With that being said, I'm going to talk about project number 3. Now, project number 3 is a little different. The reason why it's different is because it involves AI. So all my hardware over here that you see, it is designed specifically in a traditional model. You have a compute, you got your RAM, you got your storage capacity, you have, all the variables in the equation. It's not AI compatible, technically speaking. Now, to do that, you would have to put in probably a stylistic GPU that, it has the traditional outputs and all of that, but these are not friendly to 2Us and 4Us in lateral aspects. In other words, their internal components inside the 2Us and the 4Us don't really allow you to hook up effectively the right way to bridge over your connections by what we call very specialized Molex interface cables, right? Because there's no output to connect them up to. Well, that's not the case with this project. This project actually does. And what it basically will do for me is I am looking at a Super Micro Dual Xeon. Technically, it's a high-end workstation because you get the best value from the Dual Xeon workstations versus the heavy-hitting server motherboards, because they integrate desktop technologies into your functional technologies of servers. So you're getting the best of both worlds. That's why workstations, if you notice some many videos I do, I'll find as Dual Xeon workstation, and you can go hog wild with that with USB 3.0 and all these extensive features and stuff like that. But if you went to the same model make for a 2U, it was there to do storage, compute, and RAM. That's it. It really didn't have USB 3.0 and all these other variables. Not cost effectively was. If you really wanted that and to get the latest, you'd be paying out a lot of money. So with this strategy, I'm looking at this series C612 chipset motherboard. The release of it I'll put down into the video below, as I will put each related link to each of the projects I'm talking about down below in the details. The goal is I want to bring in a motherboard that has GPU support capacity, NVMe capacity, and so on and so on. And I don't mean, by the way, a SATA bridging card like this, where you can put NVMe on it and then connect it up to a SATA bridge connection. No, I'm talking about full-blown NVMe. Running off this guy and nothing else. That's firepower, right? Now, with that being said, you can also choose to put in a much more advanced card, but you have to pay attention to the details. Now, this has 4 NVMe's, right? The two 512s and 2 1 terabytes set up in a RAID 1 pairing, and that's great and everything. There's nothing wrong with that. The only challenge with that is you have to do your research, because you want to make sure that your chassis PCIe bus is properly identified for which ones you need to use. Because when you put NVMe on an 8X bus and you got 2 or 4 NVMe's, not good. And it's important because if you're going to put in an NVMe and you're going to put in a GPU card, like for instance a Quattro Pro, which is a very thin card, pretty compatible. It has low profiling, it doesn't have outputs, and the nice thing about this motherboard is it has power out for me to connect up to the GPU directly, and it's built into the motherboard. That's pretty nice, opposed to me going off and using what's called I don't know, you call it a Molex bridging, where you have to take some Molex connections, and you have here, for instance, let me show you. You can get, and in this case it's not going to be like this either. It's going to be even more specialized than this, but you can have an output on one side, and then the input, it would come out like this, and that's what you would be looking for. Real pain in the butt, it really is. So that's why the older chassis are not great at this. Can you do it? Yes, you can, but do your research. Important. Research your motherboard, research your power supply system. There is usually an option where you can output some power from a dual GPU a dual PDU, power supply redundancy output board. On that board, they'll have a proprietary bridge out, probably like a smaller connector that will allow you to connect up like a Mullix connection, and then from there you want to run that into something like this, where it will convert it into a converted power source so that you can provide power to your GPU. So the thought behind that is pretty simple. This particular motherboard, which, like I said, I'll put a link down below in the in this particular video, will also have a 12 gigabyte SAS card. Possibly, I might not do that, but I have to build this machine from scratch. So I've already bought its processors. Right here they are. And I've got memory coming, and I've got an empty chassis with a bare board on it. And so I'll be populating that with RAM. I'm going to be populating it with controller cards, disk capacity, and so on and so on. Now, it does come with the caddy chassis. That's an important detail. So just for explanation, what is a caddy? Well, caddies are pretty straightforward. You have two types. You've got a drive holding caddy, which it will take a drive and it will hold it. You have what's called a blank filler caddy, which helps you control airflow on your chassis, which you need both. And then down here you have yourself a disk chassis, which is right here, and it holds a disk. So these caddies are part of the design function of the 2U or the 4U you have. It's the same thing with disk arrays. These disk arrays also have their own caddy chassis, you can see right there. And these are empty because I'm not using this chassis right now. But like I was saying, this is the kind of detail you have to understand. You have to have your filler plates, you have to have your caddies, and the amount of disk caddies you need versus your air control. And of course, if you have like an extension media section, so for instance, hookups, outputs, drives, whatever, you've got it. And in some cases, you won't even have that option. You'll just have a little bit of media here, and that's it. And then everything else is just pure drives. But up here, this one is not complete. So I need 1, 2, 3, 4 new caddies. And these are the air blockers right here. They're designed to flow air through the drive capacitors, which are down here. And if you look closely, you'll see the airflow sets here. So that's why these caddies are important, is because they actually help flow air over the right areas and have to be met. Now, a super micro chassis is going to be very much like this guy right here. He is, these two right here are 2 1Us that I use for my high-end punchers, but I don't use them very often because they consume a lot of power. But they're a little bit different in nature. So with that being the case, I'll be able to, get all the components I need, which I'll be sourcing out using warranty component parts. That means, yes, remember, do your research. Whatever motherboard and chassis you get the manual and get the parts listing. Very critical. You need the part listings to get the correct part and piece that you need to accomplish what you need to accomplish. What do I mean by parts? I mean, it can get really, really hairy, to be honest with you. I'll see if I can't give you an example of one of those. Specifically with the Dell XD series platforms. I don't think I have it here, unfortunately. But they have a very proprietary bridge SD card. It's actually technically a mirroring SD card. And I don't know where I put it, but anyways, it's a very unique component, very difficult to source out. And I finally did find it, but it took time. And it was a little bit more expensive than I wanted to pay. I paid like $8 for it. But you can put 2 512 gig SD cards into it and boot off of those in a redundant model, which is really the only way you really should use SD cards. Never run them in RAID 0 or a single SD card because they just go bad. They too quickly. The quality levels are just too poor. So at best, you want to have redundancy when it comes to this. And are actually kind of a pain in the butt. So you're going to find parts and pieces that go into the chassis that you can say, do I really want to buy that? Do I really need that? One of those is the intrusion kit. That makes no sense to me. I'm the guy who owns it. I'm going to open up the case. You know, I'm okay. I don't need the little switch built into it and all the headaches that happen when it gets triggered and so on. And you have to go out and fix it and all of that. So yeah, it gives you a chance to go down the list, identify all the parts and pieces that are required to get things working, opposed to what we call the bells and whistles. Now, what do I mean by bells and whistles? Remember, this motherboard technically is grouped in with the workstation level, which means it's going to have some more features to it than a traditional 2U unit out here. Now, unfortunately, to my surprise, in this particular spec that I have picked out, the way they were treating it as a workstation was kind of weird, because it's still technically a 2U. So when you look at it, you know, it really does take a very specialized case housing, very much like a 19U rack chassis. But, you know, it still has the firepower of a dual Xeon SMP high-end workstation. And you want the high-end workstation, like I said earlier, for all the extra bells and whistles that you don't normally get with a traditional Intel-based or AMD-based or Opteron-based 2U chassis or 4U chassis. Now, with that, some of you might say, why didn't I go with a 4U like I have that high-capacity white chassis behind me? Well, that guy is designed to work with true desktops. There's no forgiving on those particular designs, so you need the full height of a power supply from a desktop. And you need the full height of the bridging of the height of the cards themselves, because the motherboards are usually standard PC motherboards, and but it has the ability of enabling all that functionality on the motherboard that you're surprisingly going to find out that aren't in normal PC cases. For instance, you've got a PC tower or a mid tower or something like that, and yeah, you can handle 6 drives, but not in that case. You know, it can only handle 3 or 2. And so on and so on. You know, you have the ability of doing stripe setting, and you can do like reading to Blu-ray, you know, CDRs, which are rewritable or writable Blu-ray disc burners, which are great to have, by the way. And you know, you start getting into those kind of things, and your case just doesn't do the job. That case will. So, you know, hence the mindset. It's not something I need for a GPU, unless I wanted to do more than one GPU. In this particular case design, this is a prototype chassis, so I'm only going to use one Quattro Pro NVIDIA video card that has no video outputs, unlike its counterparts, such as a 1070 or 960 or something like that, which has these outputs. The type I'm referring to doesn't have the video outputs at all. It's just a vented panel, and so it allows you to just use the onboard GPU processor so that you can inject the detection of the GPU, so that when you load the AI chat tool, it will see that there is a GPU, an authorized GPU, by the way, that is present. Do your research on that. Just don't go out there and find some basic GPU and think you're going to have it. It has to be a fully registered GPU. And usually you can confirm that by checking the list of compatibility GPUs for the operating system or the services that you're going to use for AI. With that being done, AI is pretty straightforward, but the difference having a GPU, just one GPU on board, versus just a couple of Intel processors, is pretty impressive. If you had 2 in there, it'd even be better. Technically, I could use what's called a bridge splice, which is like this. And what I could do is I could take a single connection input from the motherboard, and I could split it into 2 and then have 2 Quattro Pros, because they're thin side by side, and that would give me probably the most optimal footprint I could do on this environment. Now, realize it's a GPU. It's going to take electricity. That's the problem with you know, working with AI, is it's Intel Core and GPU intensive. So it's going to execute against your processors effectively to try to give you a timely response time frame in your environment and with what you're trying to set it up for. So in this case, I'm trying to develop a little bit different type of an AI engine that's going to support scripting, a variety of different codes such as JSON, uh, um, scripts, Bash, and so on, to use AI to better optimize how those script files should run and to be organized and structured. There are a couple out there that can do that. I'm not really interested about the chat AI engines because that's not why I'm doing this. But this would easily run a chat AI without any issues whatsoever, especially on your local capacity. Now, for those who are saying, well, what's the light pipe version of this that I could do and give me everything I want? Well, that's easy. A gaming notebook. Yep, you heard me. Any gaming notebook, an old one that has like a 1070 or a 2070 processor on board, it's fine. You just get 2 of those notebooks. You could probably get them for a couple $100 each because people want to sell them while they still work. And then what you do is you build them into a inactive state laptop cluster. In other words, you go into the operating system and you say, hey, do nothing when the lid is closed. Just use outputs only. And at that point stage, a mouse and a keyboard and a monitor, external monitor, are hooked up to the unit and the lid is closed, and that's it. Take 2 of them, put them side by side, and put them into a rack or wherever you'd like. So here I've got my Asus laptop, which I love this laptop. It's older. It's got a 1070 in it, and this guy would do just fine. But I would close the lid once I get it operational, close the lid, and I would have another one just like it. That's the smart venue, by the way. Get the firmwares and everything identical. 2 identical laptops like this, and then you can put them on their side, or you can put them in the back, or you can just make them vanish altogether underneath a table or something, and then just have your KVM switch up at the top, and then set them up in a clustered paired state, and a keyboard and a mouse, and you're ready to go. So with that being said, you're going to be able to do quite a bit actually with that setup. Can you also do this with Raspberry Pis and things like that? Not really. I mean, yeah, you could, but it's not going to work the same way. It'd be kind of slow and sluggish, to be honest with you. But it doesn't mean it wouldn't run. It's just not the same equivalency. Optimized hardware for the service is what you're trying to do here. You always want to do that for every service you're trying to run, regardless if you're trying to build like a single mode cloud service for, I don't know, storage or replication or web services or console services or database services. It doesn't matter. The point is, you always want to at least have it optimal for that regard and how it works. So with that being said, this third project of mine is to build that chassis. I'm going to do probably 3-part video on it. The first part will be probably pretty soon here because I'm already starting to source out the parts and pieces that I need, and I'll give you a walkthrough on that, and I'll have the chassis here so you can see the bare bones chassis and kind of give me your feedback and things like that. The second part will be configuration of it, and that is bringing all the parts in, operating it, getting it into a diagnostic loop, making sure everything is working and driving the right way, including having some spare disks in there for caching. Believe it or not, you need it. So with that being the case, the third part will be the AI configuration and services function. That's still going to be in development. I might change my mind and use it for something else, but for now, that's my mission statement here. So with that being said, please, give me your guys' input. If there's another kind of project you think you'd like to see, I will answer this one question that came up. Why am I not testing 100 gigabit backbones? Well, for 2 reasons. One, the standard is a little flaky, in my opinion, which means you're going to end up having a lot of proprietary nature, which means you're going to have a lot of cost. And when 10 gigabit standardized, and I said, oh, we finally are there. You saw those videos I did on my 10 gig switches, my 4-port and my 8-port. And they fully work the right way, just like a normal network switch does. And that's what you really want. You want to be careful about transceivers and converters and all those kind of things. What you want is a connection to a connection, and that's it. And that's why I haven't touched the 100 gigabit designs yet, because frankly, for a home lab, you can't use it. You really can't. Um, you could use it if you did what's called paradigming for having a topography uh, uh, pyramid style structured databasing, which means you'd have to have two highly, very fast, powerful databases running a common database. And that means that those two guys have got to be running at 100 gigs, so you can run your normal traffic at 10 gig, and so your 1 giggers can get to the 10 gigs efficiently and with equal bandwidth. No one's going to do that, and that technology is kind of dying out there because it's so complicated. I haven't done it in years, and it requires a lot of hardware for not that much of a return value. But it was extremely high available, and it was really powerful, and it was one of the first business continuity engines out there that worked. It just was expensive to do, so it wasn't very common. With that being said, also with the nature and the capacity of systems, you want to make sure also that you want standardized protocols. What did I tell you guys to always remember? Learn the protocol that everybody has to write everything to. TCP, SAS, SMTP, SNS, SNMP, DMC. The understanding of the natures of protocols that have to run, disk controller management, that's how you get disks to provide storage and use them natively, which means you can mount them and you can interact with them and you have baseline commands that allow you to use them. That's the difference between S3 kind of bucket storage and real true disk capacity, because you can't do that with S3 buckets. You can do that with anything that's virtualized out as a disk drive using DCM. There's so many other things out there, that are critical, but they're always based on roughly about 72 protocols within our industry. It's starting to grow. We're seeing some new things, but actually what's happening is we are seeing the protocols being upgraded. So TCP4 is a protocol, and it will be eventually replaced by TCP6, which has enhanced designs in it that carry the principles of TCP4 as well. Lessons learned, basically. So it's a replacement of a protocol standard. So with that being said, know your protocols. Go with the standard protocols always. What do I mean by that? Well, cloud providers right now, today, are notorious for doing this. They want to introduce their own protocols. They're trying to rename things that are traditionally known as RAID, or they might try to change the name idea of simple mail services to something of a different designation. And what they're trying to do is they're trying to rewrite the book, but it's still the same old, same old. They're just trying to become the quote-unquote experts on the topics. Learn the standard protocols. Everybody has to write their software and build their hardware to those protocols. SMP motherboard standards, that's symmetric multiprocessing. PPM, that's parallel processing mode. These are all very important protocols that dictate different types of responses and functionalities. The difference between x86 algorithms protocol versus RISC protocols. And just take the time to learn them. ARMS protocols are different than x86 protocols, and you find those on Raspberry Pis and similar devices. So even your cell phone smartwatch carries a processor and has the same kind of function. So you're learning across many different platforms supplied by many different vendors, and they'll try to make it look like their own, but they always have to have the services there, either through CLI or through some terminology in their GUI interface, which is the graphical version, like a website or something like that, so that you can make sense of it and buy their product. But it's still the same standard product. An AS is an AS is an AS is an AS. Network access storage, that's it. It's a protocol. It works and it's functional and it works everywhere. That's why we call it a standard. That's what makes compatibility work so well. So with that, the other question that came up, which I thought was legitimate, and I'm kind of looking at it. It's been a hit and miss industry. It's called photonic processing. That's basically where they're integrating light emitting communication based buses to a existing motherboard bus, and it's not there yet. I don't do cutting edge because the cost is staggering, and in this case it's not even cutting edge in my opinion, it's bleeding edge. Photonic processing, or basically fiber optic based motherboards and processors, have been around for a while, quite a while actually. I remember reading an article way back in 2002, 2001 about using fiber channel buses in a very crude way to help span PCI, which is a brand new standard coming out. And it didn't take, but it had some really great strategies that, as obviously we can see now, have been developed into something more advanced. There is something I am interested in, but it also hasn't been truly developed yet either, and that is multi-frequencing GBICs. GBICs are basically plug-in ports for fiber optic interfaces. And the multi-frequency GBICs are different than your 10 gig, 100 gig, 1 gig, or below fiber optic connections and SX or SC or LS and so on. They principally are just one emitting light and one receiving receiver, and of course one sending back the same bandwidth in a single frequency. So what they're doing is they're learning that they can introduce new NIC standards, and by the way, a GBIC is a NIC. It's just basically a fiber optic GBIC, but as over time has shown us, let me show you, GBICs have actually evolved into something quite different. The classical fiber optic GBIC, as you can see here, is as follows. It's got the traditional endpoints for the fiber optic connections, but we also have them out there as a direct connect GBICs, which is 10 gig copper direct, and we have actually RJ45 10 gig GBICs as well. And as you can see, they are just basically normal network ports using higher quality cabling, and this gives the 10 bit connection that you need in regards to having general connectivity. And so I have a paradigm of different GBICs here. Now imagine if I could say, instead of these being 10 gig NICs, I had 1,000 gigabit NICs here, and really all they were is 10 frequencies at 100 gigs each, and they are able to transmit in the same light side by side but in different frequencies through the same pair of fiber, and that's called GBIC multi-frequency emission and reception. And it's still under development at this point in stage, but it's really cool. The other cool thing about that evolving technology is it's probably going to become what we call the poor man's 100 gigabit port, which means we'll probably be able to get access to fairly cost-effective network switches that are like 4, 8 and 12 port switches that will have 10 frequency settings for a 10 gigabit connectors. So in other words, we'll have a GBIC pairing that will transmit on 10 different frequencies at 10 gigabits common, and that means basically 10 times 10 gives you 100 gigabit bandwidth, and that allows you to get that real heavy duty boost in functionality, but not really at a lot of cost, because really the investment is just in the GBICs, not in the network switch. Of course, obviously it's a hammered down version of a 100 gig NIC strategy switch, which means if you have 8 GBICs ports in it, it's going to have at least 800 gigabits of backplane speed to support 100 megabits times 8. If it doesn't, and you have to do the math to understand that, then you've got a Soho switch that isn't really built to do the job. You could probably get like 60% of that bandwidth, because that back bus is not fully, it always should be, in my opinion, if you have an uplink, it should be all of the ports bandwidth times that. So if you have 10 gigabit ports and you have 8 ports total at 10 gigabit, that's 800 gigs that you need at a minimum on the back bus, but that's still not optimal, because if you have an uplink connection, and what an uplink connection is basically, it's usually even is another fiber optic pair that's going up to your next tier switch, or your faster bus in this case. That also needs to be of equal value. And some companies, will actually put a little bit more bandwidth in there just for latency impacts that might happen. So I would say if I had 8-port switch with 2 uplinks, so I'd have the ability to span tree 2 port connections for failover, that would mean I would have to have basically 1,000 gigabytes of functional bandwidth on the back bus, so that every port can run at full speed at its capacity, its maximum capacity. That's an accurate switch, and it needs to be cheap, because if you're using multi-frequency GBIX modules, the whole point of why you're doing that is to let the poor guy have access to something at a decent price. Now, the real kicker would be the 10 times 100 GBIX, and those guys a whole different ball game. If they did 10 by 100, which should be the next exponential, that would give us a 1,000 gigabit pipe, and of course, again, you'd have to have a backplane equal to those, and those particular types of switches at a minimum are 16 to 24 ports, and they're designed to be your top dog pipe in the entire company, and there's usually 2 of them in stripe. In other words, they're set up in a spanning tree model, so that no matter what happens on either one of these guys, you never go down and you never lose your bandwidth, because it's the fastest pipe in your network. Just like a motherboard is designed, or just like a Raspberry Pi is designed, the processing power and the fastest part is in the processor itself. Then the L2 and L1 cache is the second fastest, and L3, and then memory, and then all your input-output devices like SSDs and so on, or spinning disks, or whatever you want to play with. It's the same strategy. Your network does exactly the same things the motherboard does, which is exactly the same thing that a chassis does, and so on and so on. Always follows the same standard. But with that being said, I'm sorry for this video being a little long. Usually I don't go this long, but this is really cool stuff. If this stuff interests you, just let me know. Put a little line down on the bottom, and please like the video if you think it was a good video. It's just us putting our heads together to see how can we turn our home labs into the next greatest whatever going forward. I also intend to do one other thing, and that is more home projects for your house. Things like integrating services, sensors, and things like that. How you can do that, bring that into your home, so you can have kind of like a common house screen of all of your systems and everything like that. It's kind of neat. It gets you more flexibility on what you can do in your home labs on your own time. Well, this is Brad Dyke. I'm going to let you guys go. God bless, and have a great 2025. Take care. Bye-bye.